But yeah, last talk of the day. We really are glad that you have chose to spend the end of OCP with us. And today we're here to talk about pins. So we're going to give an update on the architecture, some of the use cases, and the extensions we've been working on since then. All right. Oh, cool. So just by way of introduction, my name is Brian O'Connor. I'm a software engineer at Intel.
Reshma, Sudarshan, Director of Applications Engineering at Intel as well.
Hi, I'm Bhagat from Google.
Cool. So what we decided to do was start this talk where we left off last time, back in November of 2021 at last OCP, and just give you a quick reminder, a recap about what we were doing during our first presentation on pins. So in November 2021, we completed our MVP, the first public release of pins after 2 years of incubation. And what we provided as part of that release was a P4 runtime application for the first time to enable a remote control of the forwarding pipeline. We provided a P4 reference implementation for the SAI pipeline, including L3 admit, and VRF, routing, WCMP, next hops, and configurable ACLs, pre-routing, post-routing, and egress ACLs. We also provided packet I/O to enable packets to be sent and received by a remote control plane over P4 runtime. We provided a new ORC in Swiss with a response path to give feedback to the controller when rules were correctly inserted. And we integrated all of this with ONOS, the open source network control plane from ONF. We had some testing that we worked on internally as well at the time to validate all the functionality that we had developed. And altogether, we had a working prototype on a single ASIC. Diving into the architecture diagram, we have some yellow boxes to the right of the screen here that were added as part of pins. First, we have an SDN controller at the top that wanted to talk to a Sonic device. We added the P4 runtime service in its own Docker container. We added some new P4 RT tables, which were for our new P4 RT entries. And then we added a new ORC to Swiss that's responsible for converting those down into the ASIC-DB entries, which are our SAI objects. Next slide, please. So what have we been doing since then? So the next release of Sonic was the May 2020 release, 2205. And in that release, we completed upstreaming of all our MVP features. There were a few PRs that didn't quite make it in time, so we made sure to get those in early. We implemented batching, and there was a talk on Tuesday that went into more details on this, but this improved the performance for moving through Swiss. We added a bunch of enhancements to build and packaging. We realized there were some bugs in the way that it worked in other environments, so we fixed those. And then we, in general, got a lot of feedback as users started to pick this up and try it out. And we worked a lot of the bug fixes and hardening based on those feedbacks into our system. And finally, we also updated ONOS to better support WCMP. And if you've been in the show floor, we've had a demo of that available for folks to take a look at. And then for this most current release, the one that we're currently working on, we've added and enabled a lot of unit tests as part of the build by default. We've augmented our packet I/O support, including a new generic packet library for other Sonic applications to take advantage of the same way we do it. We've added a startup config for pins so that you can preload a configuration for your device. And we've also augmented ConfigDB to have the configuration parameters needed for controlling P4 runtime application without going in and modifying the shell script by hand. And lastly, we've been working on enabling pins as part of the upstream build by default. So we want to include that pins container and P4 orc as part of every upstream Sonic build so that people have the choice to turn it on and off without having to rebuild it themselves. There's a lot been going on in our community. And here's just a highlight of some of those initiatives. The first three, Bhagat is going to talk about next. And then the last one is going to be covered by Reshma. So we'll hand it over.
Thank you, Brian. So we heard today Rita and Arvind go through Sonic on a chassis. Really appreciate really appreciate all the effort that has gone into getting Sonic disaggregated architecture working on a chassis. Would like to follow up with pins working on a chassis. Today on a chassis architecture, from a controller point of view, we would like the controller to be able to view the chassis as a single unit, and hence we're looking at trying to bring in P4 runtime, a single instance of that in the chassis, and then work towards getting that implemented. So this is very much in an early design, initial discussions kind of a state. This is one of the things that we're starting to work on as we go forward. Compared to chassis, which is something we are just starting, pins on a virtual switch is something that has been, right from the early days, a goal for us. We strongly believe in scale-out testing and making sure that the implementation is high quality. And a great way to achieve this is getting pins on virtual implementation of a switch. And we're not talking just about control plane implementation, we're talking about even data plane testing. So the way we would like to get this happening is the complete stack, P4 runtime, Swiss, SING-D. We would like a SAI implementation, if you will, to be running in the virtual switch so that we can test not just the control plane, but also the data plane. And we have been working with multiple ASIC vendor partners to get this moving. One of the things that we are looking forward to next is getting P4 DPDK be as a SAI implementation. That's one of the efforts going on. And we're also working with any other SAI implementations that can help this move forward. Moving on to pins testing. As I mentioned, testing is a vital piece in making sure that we get the implementation that we are looking at. Pins, as you know, is based on standard interfaces. We have P4 runtime, GNMI, GNOI, GNSI, and GNPSI. The GNPSI is a network packet sampling interface. It's for SFlow. We have brought in a lot of standard interfaces, but it's also equally important to make sure when you have an API, a signature definition, every implementation of that API is similar in terms of what functionality it brings in. And in addition to just having the signature, it is also important to have proper test suits and be able to test corner cases and things like that. As you know, pins is based on a P4 program. We look at the SAI pipeline as a P4 program, so we have a very well-defined program definition, a pipeline definition that we can test against. And once you have written a P4 program, you can use a behavioral model, a BMV2 engine, to run your P4 program against and exactly say for a given packet with a given table definition and entry details, where should this packet go? Right? Once we have that, having a simulated virtual pins would allow us to test and validate this. So we do that, and we try to make sure that we run this in hardware as well. So we have a simulation on BMV2 of a P4 program that we can validate against an actual hardware implementation of a SAI pipeline and ensure that the results are the same. And what this allows you to do is this allows you to automate test implementation. And when you automate test implementation, you can look at the boundary conditions, you can do resource validation checks, you can try to fill up a table to the very 99%, 100%, and see if it still works. Right? You can really stress out the hardware. And these are things that we are doing. We want to upstream all of these tests as we go forward. And in that effort, we have started developing a test framework and a minimum test topology that will allow anybody to get this test underway. So we came up with two libraries, ThinKit and Ondetra. Ondetra is something that is already open sourced, and the framework is upstreamed. There's a GitHub, which is open. ThinKit is something that we are working on upstreaming. And we are looking at combining both ThinKit and Ondetra and providing a model where you could run things on a BMV2 simulation and take it all the way to hardware and validate that what you see in your behavior model is exactly what you see in hardware. And you have end-to-end coverage in terms of all kinds of functionality, corner cases, etc., in your testing matrix. So this is a framework, a mini topology, as well as a set of test suites that we are looking at upstreaming. From here, Reshma will.
With the aim to allow logical extensions to the standard SAI pipeline, generic SAI Extensions adds the infrastructure in Sonic to realize novel features by adding new match action tables in the SAI pipeline.
It gives the user the flexibility to extend their existing SAI features or protocol or add proprietary IP in their applications that they want to write in the secure environment of Sonic pins and have the uniform management interface across all their applications as well as the devices in their network. The users assume the underlying SAI pipeline as the baseline and create new tables as touch points to extend SAI features. By adding a couple of match action tables in the few places in the pipeline, and they are programmed in a way that is independent of data path. The new match action tables could change the metadata that's used in the SAI pipeline, or they could add new metadata that is not going to be used in the pipeline's regular flow. Next slide, please. Here are some of the use cases that we think can benefit from the generic SAI extensions. Common use case across all networks is congestion management. Network is a primary concern given the requirements of high bandwidth and low latency, and to meet the SLAs, the congestion management becomes vital. To attain end-to-end congestion control, we need the intermediate devices in the network to participate and monitor buffer thresholds and report back the first site of congestion back to the source. And this requires changes in the pipeline where generic SAI extensions can help. That's fine. No, the same. Yeah, thank you. For load balancing applications, latency and performing power become very important. And high CPS load balancing with the policies controlled by the SDN is a widely deployed scenario today in cloud infrastructure. Generic SAI extensions can help with adding flow table lookups, as well as SDN managed stateful firewall. And of course, all these have separately been discussed, and this gives the optionality for user to use the generic SAI extensions to also achieve that, like we have been discussing in the Dash community. SRv6 gateway, I'm going to skip the BNG for the moment. The SRv6 gateway has to terminate the IPv4, IPv6 traffic and originate the SRv6 tunnels. And the proxy helps, the SR proxy helps with certain portions of the network that are SR unaware, and also to bridge the SRv6 islands. So the service chaining as well need the network functions like CGNAT and firewall to be run on the devices in the SR-aware network. And for all this, we need NCAP, DCAP, and manipulating some network headers with the predefined policies as set by the SDN controller. Customer-specific network headers, what I mean by that is that when the customers want to transition from the existing technology to the new technology to be backward compatible, they always have some opaque information. They have the flexibility to achieve that with certain information of their own while they transition to the new technologies. Recalling the pins architecture in Sonic, we propose these enhancements that will allow a more generic way to program this extension tables. The P4 runtime intercepts the P4 information from the P4 info from the controller and translates that extension table match action fields into the application database. It also builds a table definition database that is needed to record the inter-table object dependencies. And in P4org, we now add a new extensions tables manager that will process these tables and builds a dependency graph. It first creates the object type key value pair and looks up the dependent object and its associated cache, and to retrieve the object ID to make the corresponding SAI calls and add the entry into the ASIC database. Overall, this aids in cross-referencing between objects in the extension tables, as well as between the extension tables and the existing SAI objects in pins. And in the future, we will also add cross-referencing between extension tables as well as the SAI objects added by the local control plane. Yeah, please. The extended pipeline traits are fully programmable through this SAI interface. We propose a new SAI object that can more generically program the extension table match action fields, and the programmable object takes in the values and the required metadata to program the extension table entry into the target hardware. We have been working with the SAI community to ensure that the required metadata and the details are captured in the attributes of this new SAI object for the extension tables. BNG use case, again, this is a very simplified representation of what BNG entails. So we map the incoming tunnel packet with the C tag and S tag, and then map that to the subscriber ID. And this can be eventually used in the metering and accounting that BNG needs, for example. So from the traffic that comes from the home gateway to the broadband network gateway, we'll need the termination of PPP or Ethernet, for example. So the blue box here is something we can use to implement the PPP or Ethernet tunnel termination, or we can have a small exact match table as well. All this is up to the user, gives the flexibility to add new tables as needed, like the first red rectangle here that shows. We can have a loud list here to make sure that the traffic that comes in is something that this broadband network. Yeah, we are very excited to bring the generic SAI extensions into the community. We have completed the review call in the Sonic community as well, and we plan to upstream it this year. So please join and make this much wider option. Thank you.
Questions?
In the Sonic VS slides, they're mentioning using Sonic-based VS-based on the DPDK. I heard earlier today there's a talk about having SAI on top of iDPDK. Is this the same thing, or is this okay?
Yeah. So we want to have a P4 DPDK, that is P4 programmable DPDK, running in the host and enable Sonic in the VMs. So we could have full pins match action pipeline implemented in the host using P4 DPDK, which is performant, and have multiple Sonic VMs. That's a goal for this project that we have, and we want to complete it like early next year.
So we'd like same efforts, right? So
yeah, we're using the same code path, same effort.
Yes, yeah.
We're taking DPDK, TDI, and then this SAI to TDI mapping, and putting that all together to create a DPDK-based Sonic switch.
Thank you.
Question for Bhagat. So I don't know if this is a simple question or a complicated question, but what use cases at Google are you looking to use pins for? Are you planning to use it in your data center fabric? Why are you interested in it?
So two reasons Google is interested in general. First of all, we're interested in SDN. We want to make sure that SDN becomes popular, and we would like to make sure that Sonic can be augmented very easily to support SDN throughout the data center use cases. Right? So that is the goal that we started with, and we have already achieved a lot of that in this last couple of years. The next thing that we want to do is be innovative, add more and more scenarios where things can be used. And the generic SAI extension gives us these capabilities. And in some of the use cases that we went through in that slide, one example is the congestion use case. We really believe that we could do a lot of innovative things in congestion control. And that's something that we are trying things out on. And to some extent, this needs one to iterate faster, if you will. So rather than completely do the theory work and then come with an API and get it through a community and then try it in the stack, we would like to iterate using a generic extension, if possible. And then once we have something that we know is working very well, we'd like to bring that to the community through a standardized API. So the generic extension really brings us the capability to iterate very fast, try different things, and then make it standard, if that makes sense.
Yeah, but you're planning on using it inside of Google.
Yes, we are looking at in different use cases. Yes.
Okay.
Do you want to
Because
mention
outside of
traffic
Google,
engineering or WCMP?
Sorry.
yeah, outside of Google, I guess maybe for use cases outside the data center, possibly for like BNG and stuff like that. I'm just curious. I'd like
Oh,
love
absolutely.
to see a line of sight between, because I think it's really great, and but I'm trying to see like how are you going to land it? Like you could eat your own dog food and you can demonstrate that you're using it at Google, but if you're doing it for the community, then I'd like to see that the community actually is responding to it from a consumption point of view, not just purely from a research and more of an idealistic point of view. I'm just trying to see where it connects into real adoption for the community, or if not the community, inside of Google.
Oh, this is definitely not just for Google scenario at all. Right? We want to build a robust community that uses Sonic for SDN. And we want more customers to build controllers and start using them in a way. What we have done here is enable the standard paths automatically in the green path, and then be able to support additional use cases. Brian was just talking about WCMP, and one of the things that we want to do is have the ability to install routes even during traditional locally running BGP apps and etc., and then be able to adjust the weights, if you will, from a controller perspective, right?
Yeah,
and that's
controllers are hard.
yes, controllers are hard.
Okay.
Yes,
I mean, almost this is easier compared to a controller, right? Because these are very primitives, basically. Controller has to have system knowledge, and it's a hard problem to get it right. Because if you don't get it right, you break everything.
yes,
Right, really badly.
yes.
And so then the question is, you guys brought Kubernetes to the community. Do you plan to bring a controller to the community? Is that what's next?
That is something that is still being discussed, still being debated and discussed around. So while controller is hard, one of the things I want to say here is also that if you want to bring a controller that supports every use case or everything from grounds up routing and etc., that's a much harder problem. But with pins, what you can do is you can start things. A lot of things can happen locally using the local apps, and then you can enable a particular functionality, say be it load balancing, be it adjusting the weights, or different things, and bring in specialized functions through controller. And we would like to see a controller becoming more and more common, and people starting to think about controllers being easier as we go in, right? So one of the things that has been different from the last time we attempted this 5-6 years ago to now is that we are making sure that incremental value adds are possible this time, rather than say that, okay, it has to be a monolithic thing, right? Because monolithic things are hard, and controller, even if we open source a controller, it's going to be very hard for somebody to maintain it and run through it and so on. So it's definitely not easy. So the goal this time is to start doing incremental stuff and slowly make a community come together on this particular aspect. One of the things that has happened over the years is also that previously a network used to be across multiple domains, and there was no single administrator. Now we are having use cases where a single administrator is in charge of multiple switches. And those are scenarios where a controller can be really, really useful. And that's what we want to bring.
Just to add to
Sorry,
what
I
Bhagat
think
is saying.
we have one more question. Maybe I would
Right.
line.
Just want to say that, for the use cases that I just mentioned, right, they are real use cases and we are actually trying them out, and we are working with some partners as well at Intel to see how we can demonstrate that using generic SAI extensions. Some of them have already been prototyped, but we will work with them and see how, how they can be sort of maybe made public too at some point.
Thank you.
Thanks a lot, guys. Great talk. Just a quick question on this virtual switch testing. Bhagat, you mentioned about, in order to carry out the testing for all the data plane testing and so forth, there was a DPDK support as well as bringing the SAI over the DPDK. Have you guys thought about the VPP or bringing, perhaps the SAI over the VPP to carry out the data plane, within the virtual switch?
We are not married to a specific implementation of SAI when it comes to virtual. What we want to encourage is more and more possibilities of a virtual SAI implementation. The biggest benefit we see is that once you have a virtual switch and you have a test suite, you can scale out testing, you can farm out the test, and you can have a huge number of parallel tests that are running, right? For example, one thing we want to make sure, especially, is quality of the stack. And to ensure high quality stacks, we would like to even bring in a scoring system based on the test. So the scoring system generally means that you have to run all the tests you have within a limited period of time. So an image comes out, right? And it runs through this huge package of tests and gets you a score qualifying that image to be a particular level of quality. And if there is...
You have to have a target, in the virtual area, whether it's a DPDK or VPP or in this case BMV2 or whatever the case, right?
Yes.
So you're saying that there will be just one virtual SAI to take care of all those?
So I think it'll be, what we do today is we have two test targets. We have BMV2, where we don't have a SAI front end to, but that's what we can use to validate our forwarding pipeline and actually simulate the passing of packets. Then we have Sonic VS, where there's no data plane, but you can send in SAI stuff. So we use a combination of both SAI VS, or Sonic VS and BMV2 to sort of achieve the SAI and data plane testing that we want for the features we've been developing. DPDK will marry that together to some degree, where we'll have an actual high-performance data path with an actual SAI implementation on top. If you wanted to take VPP or something else and provide an implementation, we could certainly take that. It's just the DPDK work was already something we had ongoing at Intel, and so we're just trying to leverage that too.
And from the architecture standpoint, we'd like to support the newer P4 architectures, which are PSA and PNA. So these are the two architectures we'd like to support.
Thank you, guys.
Once you run them in virtual, you do want to come back to hardware and run it in hardware as well, because at the end of the day, your product is, it needs to run on a hardware switch, right? So this is an incremental step to validate the top half of the stack, if you will, right? Everything above SAI, and to validate that part very fast, so you can iterate very fast on that part. And after that, you do want to come back to the real hardware and run it there. So irrespective of which SAI implementation it runs on virtual, we still need to eventually come back to the hardware.
Thank you so much.
It's a shift
Thank
left
you.
for development.
Yeah. Sorry, we're way over time now.
Thank you very much for the interest. Really appreciate it.